The ocean is a vast, complex environment. When we consider how militaries operate across the globe, it raises a key question. Does the U.S. Navy actively keep track of ocean temperatures?
The answer is a clear yes. The U.S. Navy not only takes ocean temperatures, but tracks them systematically. It is a critical component of their operational missions and their scientific endeavors. In fact, the Navy has been doing this for decades through organizations like the Fleet Numerical Meteorology and Oceanography Center, or FNMOC, which started collecting temperature data way back in the 1950s.
So it is not just a passive collection, it is an active, vital part of what they do. What kind of tools and technologies are we talking about when the Navy collects this data? It seems like an enormous undertaking given the sheer scale of the oceans.
It certainly is a huge undertaking. The Naval Oceanography Operations Command uses an array of tools. This includes buoyancy gliders, drifters, and satellites, along with traditional ships and unmanned underwater vehicles. All these collect real-time ocean temperature data. This information then feeds into high-performance models run by the Fleet Numerical Meteorology and Oceanography Center, or FNMOC. These models, like the Global Real-Time Ocean Forecast System, or RTOFS, and regional ENCOM models, generate detailed forecasts of sea surface temperature and ocean currents. They are initialized with observational data from satellites and in situ sensors.
That is a sophisticated network. Can you elaborate on the role of satellites? How do they provide continuous measurements, and how accurate is that data?
Satellites from both NOAA and the Navy fleets, equipped with instruments like VIRS and microwave radiometers, provide continuous sea surface temperature measurements. These are essential for tracking climate trends, marine ecosystems, and for specific operational planning. The Naval Oceanographic Office, NAVOceano, processes an incredible amount of satellite data daily. They handle over 150,000 satellite SST retrievals daily, with high accuracy, reporting monthly bias errors under 0.1 degrees Celsius. They rely on sensors like the Advanced Very High Resolution Radiometer, AVHFR, and VIRS, which detect infrared radiation from the ocean surface for continuous, high-resolution mapping. They also use data from the Defense Weather Satellite System, DWSS, for tactical applications.
It sounds like a robust system for surface data. What about deeper measurements or long-term persistent monitoring in remote areas? Are autonomous platforms involved, and what does the source say about cutting-edge concepts like energy harvesting from the ocean itself?
Absolutely. For deeper and long-term monitoring, the Navy deploys autonomous platforms such as buoyancy gliders, drifters, and profiling floats, including Argo floats. These devices move through the water column, measuring temperature and salinity at various depths, and can operate for months, transmitting data via satellite in near real time. There is also the DARPA Ocean of Things program, which aims to expand this with low-cost, environmentally safe floats to create vast sensor networks. The Navy has even developed energy harvesting systems like the PSAP Voyager. This system uses differences in ocean temperature to generate power, enabling long-endurance undersea hydrophones and sensors to monitor both acoustics and thermal profiles.
So they have an extensive data collection network, from satellites to deep-sea autonomous systems. How does all this diverse data get integrated and turned into actionable intelligence for naval operations and scientific research? What are the strategic implications of having such comprehensive ocean temperature data?
All this data is integrated through the Navy-Coupled Ocean Data Assimilation, or NCODA system. NCODA combines satellite, buoy, and in situ data into models like the Global Real-Time Ocean Forecast System, RTOFS, and regional ENCOM. These models then produce high-resolution forecasts of sea surface temperature, currents, and the ocean's thermal structure. This is critical for various strategic applications. For anti-submarine warfare, understanding thermal layers allows submarines to exploit them for stealth. It is also essential for navigation and fleet safety, as well as for broader environmental monitoring and climate research. By maintaining this persistent ocean-observing network, the Navy ensures tactical superiority and significantly contributes to global oceanographic science.
It is clear that the Navy's extensive efforts in tracking ocean temperatures serve dual purposes, enhancing their operational capabilities and contributing valuable data to the broader scientific community.
Indeed, this systematic collection and analysis of ocean temperature data underpins critical tactical decisions while also advancing our understanding of the ocean as a whole.
If you found this discussion illuminating, consider sharing this episode with someone who might also find it interesting.
Rachel, it's been over 10 years since Naomi Klein released her book, quote, "This Changes Everything," end quote, which framed the climate crisis as a fundamental conflict between capitalism and the environment. For a time after its publication, it really seemed like significant progress was on the horizon, with growing calls for a Green New Deal and major companies announcing ambitious net zero targets. What happened to that momentum?
You're right, Jake. There was a period of genuine hope with militant mobilizations pushing for keeping global warming below 1.5 degrees Celsius, and even some of the world's biggest companies and nations committing to long-term emission cuts. However, that was followed by a multifaceted backlash, largely funded by corporations. We saw this most clearly with the Trump administration, which within its first 100 days implemented over 140 measures designed to weaken environmental regulations and aggressively promote fossil fuel use.
Over 140 measures? That sounds like a systematic dismantling of environmental protections. What were some of the key actions taken, and how did that impact the broader climate effort?
It was indeed systematic. Trump's administration filled his cabinet with proponents from the oil industry, deliberately weakened federal agencies that were at the forefront of addressing the climate crisis, and canceled crucial environmental justice initiatives that had the potential to save lives. He also signed executive orders that eased restrictions on fossil fuel extraction and export. This created an environment where the very banks and companies that contribute to our climate catastrophe felt emboldened to revert to old ways.
So it sounds like this political shift provided cover, almost an excuse for these financial institutions and corporations to abandon their earlier climate pledges. But why pivot back so quickly? Was it simply about opportunism or something deeper? Specifically, we are seeing banks and other large companies retracting their renewable ambitions and going back to funding fossil fuels, right?
It was a combination of factors, but two primary drivers stand out, which is what the source points to: an apocalyptic fear of regulation and the pursuit of what the source calls super profits. These powerful entities, once they saw the political landscape shift and the world's most powerful man actively assaulting the planet's environmental protections, let their, quote, masks slip, end quote. They dropped their stated renewable ambitions because the threat of regulation diminishing their profits was lessened, and the immediate financial gains from fossil fuels became too tempting to resist.
That's a powerful way to put it. It suggests that many of those initial commitments were perhaps conditional or strategic rather than deeply ingrained values. And this fear of regulation driving the pursuit of super profits seems particularly problematic given the urgency of the climate crisis.
Exactly. And this corporate and political reversal is also amplified by another serious problem: climate misinformation. According to a thorough study, this misinformation, often spread by far-right and right-wing populist politicians, has become so pervasive online that it risks turning a crisis into an absolute disaster. It erodes public will and creates political space for these companies to backtrack without significant public or regulatory pressure.
So we're not just seeing a withdrawal of pledges, but an active effort to undo progress driven by financial incentives and enabled by a deliberate campaign of misinformation. It brings us back to Naomi Klein's original thesis that the climate crisis is inextricably linked to the workings of our economic and political systems. It seems the fight she outlined in This Changes Everything is far from over.
That's certainly the clear takeaway. The initial optimism that followed calls for a Green New Deal and corporate net zero targets proved fragile against the combined forces of corporate backlash, political deregulation, and the allure of massive profits in the fossil fuel industry, all while climate misinformation spreads unchecked. If you found this conversation insightful, consider sharing the episode with someone who would appreciate it.
Does the U.S. Navy keep track of ocean temperatures? Yes, the U.S. Navy actively takes and tracks ocean temperatures as a critical component of its operational and scientific missions. Naval Oceanography Operations Command uses a wide array of tools, including buoyancy gliders, drifters, satellites, ships, and unmanned underwater vehicles, to collect real-time ocean temperature data. This data is used to monitor and predict conditions that affect naval operations, such as submarine performance, acoustic propagation, and fleet safety. The Fleet Numerical Meteorology and Oceanography Center runs high-performance models, including the Global Real-Time Ocean Forecast System and regional ENCOM models, which generate detailed forecasts of sea surface temperature and ocean currents. These models are initialized with observational data, including SST from satellites and in-situ sensors. Satellites in the NOAA and Navy fleets, such as those equipped with VIIRS and microwave radiometers, provide continuous sea surface temperature measurements, which are vital for tracking climate trends, marine ecosystems, and operational planning. The U.S. Navy's data assimilation system integrates satellite, buoy, and ship observations to produce accurate, real-time SST analyses and anomaly maps, supporting both tactical decision-making and long-term environmental research. The U.S. Navy systematically collects and tracks ocean temperatures using a wide range of advanced technologies and platforms to support both operational and scientific missions. Primary methods of data collection: satellites. The Navy uses satellite-based sensors, such as the Advanced Very High Resolution Radiometer and VIIRS, to monitor sea surface temperature globally. These instruments detect infrared radiation emitted by the ocean's surface, allowing for continuous high-resolution SST mapping. The Naval Oceanographic Office processes over 150,000 satellite SST retrievals daily with high accuracy, monthly bias errors under 0.1 DGC. U.S. Navy Satellite Sea Surface Temperature Monitoring. Autonomous platforms. The Navy deploys buoyancy gliders, drifters, and profiling floats that move through the water column, measuring temperature and salinity at various depths. These devices can operate for months, transmitting data via satellite in near real time. The DARPA Ocean of Things program expands this with low-cost, environmentally safe floats to create vast sensor networks. Unmanned and manned vessels. Autonomous underwater vehicles and unmanned surface vehicles are equipped with temperature sensors for persistent ocean monitoring. Navy ships and submarines also carry oceanographic sensors, feeding real-time data into operational models. Energy harvesting systems. The Navy has developed systems like the PSA Voyager, which uses ocean temperature differences to generate power, enabling long-endurance undersea hydrophones and sensors that monitor both acoustics and thermal profiles. Data integration and forecasting. The Navy Coupled Ocean Data Assimilation System integrates satellite, buoy, and in-situ data into models like the Global Real-Time Ocean Forecast System and regional ENCOM. These models produce high-resolution forecasts of SST, currents, and thermal structure, critical for submarine operations, mine warfare, and acoustic planning. Ocean temperature data directly impacts anti-submarine warfare, navigation, and climate resilience. By maintaining a persistent ocean-observing network, the Navy ensures tactical superiority and contributes to global oceanographic science. Strategic applications. Ocean temperature data is essential for anti-submarine warfare, navigation, and fleet safety, environmental monitoring, and climate research.